Alright, so this is page 25 in Module 5. So we're going to learn about perpendicular lines. So let's look at this right here on the side. Two lines, line segments, or rays are perpendicular if they intersect to form 90 degrees angles. So remember, intersect means cross, right? Where the two lines or line segments, they intersect, where they cross to form 90-degree angles. So 90 degrees, we know that it's a right angle. The symbol for perpendicular is this. So if you see this symbol, that means that's perpendicular. Okay, that the lines or line intersects or rays, they cross to make 90-degree angles. So let's see, right here, number 1, it says, draw and label line AB perpendicular to line CD at point E. How many right angles are formed? So we would have to draw a line AB and then line CD crossing or intersecting to form right angles at point E. So where they intersect, where they cross, we should have a point E. So just like this, right? So we would have line AB and line CD, and when we draw that and they cross at point E, we form how many right angles? 4 right angles. This is 1, 2, 3, 4. So each of them is measured 90 degrees. So how many right angles are formed? We say there are 4 right angles. Number 2, draw and label line BC perpendicular to line AB at point B. Okay, how many right angles are formed? So it's exactly the same, you're just going to have to label it differently, right? BC and AB, so AB and BC. So instead of CD, you're going to have to put BC, and instead of E, you're going to put B. So it's basically the same thing as number 1. Now number 3, name all angles that you know are right angles in the figure shown. So note, points A, D, and B lie on the same line segment. So when points lie on the same line or line segment, they are said to be collinear. So these are collinear because they lie on the same line segment, right? So let's just list the right angles that we know for sure are right angles. So first of all, this symbol right here in black, this square symbol, this indicates that it's a right angle. So we can say that angle ADC is labeled 90 degrees. So we know that that's a right angle for sure. And secondly, we know that since angle ADB is a straight line, we know that angle BDC, so BDC, is supplementary, then it must be 90 degrees also. So since we figured out that, first of all, since this was given to us, this is 90 degrees, and since we know that this is a straight line, we know that a straight line must be 180 degrees. So this angle right here, plus this is 90, should be 180 degrees. So if you subtract 90 from both sides, we know that x is equal to 90 degrees. And that makes this a right angle. Okay? And lastly, we have, since angle DCF, so angle DCF may or may not be 90 degrees. Because it appears to be, but just by looking at it, it looks like it's 90 degrees, but we can't really say for sure it's a 90 degrees because the segments CF may not be parallel with segment DB. Okay, so if this was, for example, it looks parallel, but we can't say for sure because it's not labeled as with the 90-degree angle sign, and it may be a little bit like shifting towards to the right or so. So then if these are not parallel, then we can't say this is a 90-degree angle.